Hey guys, welcome to Empty Stack and you are watching LeetCode series of problem solving using Java, and today we are going to look at best time to buy and sell stocks. To solve this question, it is good to have knowledge on arrays. The difficulty level is easy and this question was asked in interviews for companies like Microsoft, Facebook, Bloomberg, etc. Let's jump into the question. We are given an array prices where each element in the array represents the price of the stock on that day. We need to maximize the profit by choosing one day to buy the stock and another day in future to sell the stocks. We need to maximize our profit, and if it is not possible, we simply return 0. Let's look at an example. Here each element in the array represents the price of the stock. Like on day 1 it was 7, day 2 it was 2, day 3 it was 5 and so on. Now we need to select one day to buy the stock, say day 4, and one day to sell the stocks, say day 6. So our profit would be 1. But ask here is to maximize this profit. Let's visualize this data using a graph. Now here we see that if we buy stocks on day 2 and sell it on day 5, we get a profit of 4, and that will be the maximum profit. Using the same example, let's try to form an approach. From the graph, we can clearly see whenever there is a dip in the graph, it is a good time to buy the stock, and whenever there is a peak, it is a good time to sell the stocks. Also, we know we cannot buy and sell on the same day. Let's analyze further. Say if the graph was always going down, we would always make a loss. So in those cases, we shall not do any transactions, thus making 0 profit. Keeping this in mind, we can say initially best case profit can be set to 0. Now let's try to traverse over this graph. On day 1, we see the value 7, say we buy the stock on this day. But the very next day, we see a dip and the value goes down to 2. So it wouldn't make sense to buy on day 1, and rather we should buy on day 2. We see another dip on day 4 to value 3, but it wouldn't help in making more profit as we have already seen a lower value in past. But what about day 7? We see value goes down to 1, and this could be a case where we could have made more profit. If say on day 9 the value jumped to 8, then buying stock on day 7 would have been more profitable. So we can say if we keep track of the lowest value of the stock so far, it could be useful to us as it could be a potential day to buy the stock. Let's talk about selling the stocks. We can see till day 2, we know that the lowest value so far would be 2 only and the best case profit was 0. So what if we sell the stock on day 3? We would make a profit of 5 minus 2, that is 3, which is higher than the initial value of 0. So we can update best case profit to 3. So we can say that if on each day we check the profit we could make by selling the stock on that day, and if it is higher than the current value of best case profit, we could update it with this value. Let's continue with our example. So we move to day 4. If we try to sell on this day, we would make a profit of only 1, which is lower than the current value of best case profit. So we move to day 5. Now we see that the value has gone up to 6. If we sell on this day, the profit would be 6 minus 2, that is 4, which is higher than the current value of best case profit. So we update best case profit to 4. Now till day 7, we only see a drop. So no change anywhere. But on day 7, the lowest value so far has gone down to 1. So we have a new value for it. But on day 8, if we try to sell it, we will only make a profit of 3, which is lower than the current value of best case profit. So we do not make any updates and we return 4 as the maximum profit. Keeping these points in mind, let's try to form an algorithm for this. So we know the input would be an integer array having prices, and we can start by defining some variables. We will define best case profit that will have maximum profit, and as discussed we will initialize this with 0. We will also define least value so far and initialize it with infinity so that we can update it to lower value as we find them. Next we iterate over the prices array, and in this, if current price is less than the least value so far, we'll update it with the current price. Also on each day or in each iteration, we will check the profit we could make on that day by subtracting least value so far from the current price. If this value is more than the best case profit so far, we will update best case profit with this new value. And that would be it. The complexity of this algorithm will be O(n) as there is a single loop in this. Okay, let's look at the Java solution. We start by creating best case profit and initialize it to 0 and least value so far and initialize it to integer.max value. Now we iterate our prices array and in each iteration we get price today. Now if it is less than least value, we assign it to least value. Now we need to get the profit if we sold the stock today by subtracting least value from price today. We define this variable. Now we check if this value is greater than best case profit. We update best case profit with this value. Finally, we return best case profit. We add some edge cases. If the input length is 1, we can simply return 0. Let's run this. Perfect. See you guys in the next one.